Alright, so this is part 2, and we're just going to crank out some examples after writing down the formula. So here is the formula we're going to use, wash, rinse, repeat. It's called the fundamental theorem of calculus, part 2. We already did one earlier with derivatives and integrals, but this is cool. This is basically what we just did at the end of the last video. So the fundamental theorem of calculus says if you have the integral from a to b of f of x dx, it equals, notice I'm doing a capital f of x evaluated from a to b, which splits up into the capital F of b minus the capital F of a. So basically, remember when we do a capital F, it's the integral. That's where we do our antiderivative trick. So it's the antiderivative of this guy where I do my trick. And if I want to evaluate from b to a, I plug in the upper limit first and subtract off the lower limit. And remember, this all goes back to the picture of if I want the integral from a to b and just the area between here, it's like taking the integral of the whole thing, that's what this is, the area under it from all the way back, and subtracting off the part you don't want. Right? So here's the area from A back, and here's the area from B back, and I'm left with my winner from A to B. Alright, so let's crank out some examples, and this gets pretty easy, it's pretty cool. Alright, so this example, let's do the integral from 2 to 5 of 3x squared minus 5x dx. So to do this, I just do my antiderivative rule, which is to take 3x squared over, I raise the power up 1, over the new exponent minus 5x squared over its new exponent. And this is evaluated from 2 to 5. Notice I put brackets around it. There's another way to write this too, with like a straight line down that you may see. I'll do the next one with that notation. But before I start plugging in things, I'm going to clean this up a little. I just like looking at it like this. Okay. So 3 over 3 canceled, and 5 over 2, I like to write it in front. So now if I want to find the value or the area under this curve, crazy looking curve, you should never have been able to find the area of this weird shape before. It's not a triangle, it's not a hexagon. From 2 to 5, basically we just plug a 5 in first. So I'm going to put 5 to the third minus 5 over 2 times 5 squared. And then I'm going to subtract off, plugging a 2 in. 2 to the third minus 5 over 2 times 3 squared. Okay, I put them in parentheses. I highly recommend this. The more steps you do here, the less likely you are to just get a computing error and get the wrong answer. Even if you did all this work right, I get people who type it in too fast or try to do it all at once and they get it wrong. So we're going to go kind of step by step with our calculator, and I'll just do this part, get an answer. Separately do this part, get an answer, and then subtract them at the end. I promise you it will keep you from making mistakes. Alright, so let's do this first one. 5 to the third minus 5 over 2, I'll put in parentheses, but it wouldn't really change it. 5 over 2 times 5 squared. Right, so that's this first part. Boom, and you get 62.5. Okay, you can always store that number in your calculator for later if it's a crazier answer than that. The other one's 2 to the third. Actually, I can just go back up here. And, oh geez. Okay, so we'll go 2 to the third. Boom. And it's a good idea to put those in parentheses, actually. They weren't negative, so I didn't worry too much about it, but we'd be better off if we put our, like I wrote them, put them in, what the heck? Put them in parentheses. And then if it was negative, I wouldn't get the wrong answer. Okay, so that's a -2. And this is why I write these out, because you could get this wrong otherwise. 62.5 minus -2 is the same as 62.5 plus 2. 64.5. So that's crazy. And if you looked at a picture of it, here I'll pause this and make my calculator do the work. So if I looked at a graph zoom 6 this thing. So if I looked at a graph, what I'm saying is the area of this curve between 2 and 5, way up here, it's off screen high, is 64.5. And it's not just approximately 64.5 with using rectangles. It is exactly 64.5. So what's crazy is your calculator can actually check this. If you do second calc, you had like zeros and maxes and mins, you can actually find the area to check your answers. The lower limit is 2, the upper limit is 5, and I can check my answer. Boom, 64.5. Sweet. Okay, so that's a great way to check your answer. There's problems where your calculator won't do the job, so you got to be careful on that. So yeah, let's do a couple more examples and you'll get comfortable with this stuff. All right, so to get us ready for these kind of things, let's do a couple more examples and crank out a few more. So I wanted to do one with a negative in there to show you got to be careful, because if you type in your calculator and you don't get the same answer as me, you done messed up, Ron. Okay, so I'm going to do my integral thing. So I take the exponent up 1 and I divide by the new exponent. I take the exponent up 1 and I divide by the new exponent. I take the exponent up 1, and dividing by 1 doesn't do much. Now here's the other notation. I could put it in brackets and go from -3 to 4, or I could do this. It's just another way to write it. It means the same thing. Basically, you're still splitting this into 2. You're going to write 4 to the 5th over 5 plus 9 times 4 squared over 2 minus 4. If you don't use parentheses here, I bet you get it wrong. Really, it's on the back part, because -3 to the 5th over 5 plus 9 times -3 squared over 2 minus -3. Okay, just take your time and write them out and subtract them at the end. Just do it. You will be better for it. Okay, so I'm going to go, I'm going to do the negative part first, just because it's, I'm going to type that in, -3 to the 5th divided by 5 plus 9 times -3 to the 2nd over 2, and then minus -3, so I can just put +3. So I type all that in, I get -5.1. Okay, and then remember, there's still a minus here. Don't let that cancel that out in your brain. Then I go back up. I don't want to type all that again. So I go here and put, this turns into a regular 4, right? This turns into a regular 4, and this turns into a -4. Okay? Boom. That's 272.8. And then I'm doing minus -5.1, which is plus 5.1. Because minus a negative is plus a positive. And you get 277.9. Boom. Okay, let's do one more, kind of a weird one. That's like a fraction one, just to remind you what that's like. All right, so this will be our last one, and it's a good, reminder of some of the weird stuff here. If you have a division problem, there is no quotient rule. There's no anti-quotient rule, so you have to split it up into its 2 parts. Remember, 1/2 power is like a square root. So basically, notice I'm not removing the integral sign, because right now all I'm doing is simplifying this problem. I'm not doing the antiderivative yet. First, I need to rewrite my stuff. Okay, and then this simplifies before I do my integral trick. Okay, and this is what you have to do every time you have a fraction with this. There is something called integration by parts that you will learn in Calculus 2 in college, but we're not there yet, so let's not deal with that. So when you have a power divided by a power, you subtract the exponent, so it's really 2x to the, and if you take, this is 4/2, right? 4/2 minus 1/2 is 3/2. And then this is a 1. 1 minus 1/2 is 1/2. Now that I can take the integral of. Okay, so here is where I'm going to do the integral from 1 to 16. Okay, the antiderivative of this, it's going to be 2x to the, I'm going to raise this up 1, and what's 1 more than 3/2? It's 5/2. Now, dividing by the new exponent is tricky. Instead of dividing by 5/2, I can multiply by 2/5 by its reciprocal. That's a good skill. Dividing by a fraction is the same as multiplying by its reciprocal. Remember, you don't use you don't do the division until you got your new exponent. The next one, what's 1 more than 1/2? It's x to the 3/2. And instead of dividing by 3/2, I can multiply by 2/3. Cool. Now, it splits into two. Maybe I'll clean this up because this bothers some people. Remember, this is over 1. So if I multiply those, I'll have 4x to the 5/2 over 5 minus 2x to the 3/2 over 3. Evaluated from 1 to 16. Whew, this is a longer problem. Now it finally splits up. You're going to like the 16 and 1 because, remember, half powers are like square roots. So you're going to have 4 times 16 to the 5/2. And then, remember, you plug the whole thing in with 16s, and then you'll plug the whole thing in with 1s. Okay, so we'll do the same thing. 4 times 1 to the 5/2 over 5 minus 2 times 1 to the 3/2 over 3. This side's easier because 1 to any power is still 1. So really this comes down to be 4/5 minus 2/3. Okay, this side, maybe I'll do them one at a time like the pieces. You know, the more you write, the less likely you are to make a little error. Okay, my battery's low. So I'm going to have, I want to find out what 16 to the 5/2 is. So in parentheses, 16 to the 5/2. Boom, is 1024. And then I'll go times 4/5. Boom. So that's 819.2 minus, and now I'll do it kind of in reverse here again, 16 to the 3/2. Yeah. Is 64 times 2/3. And we get 42.6 repeating. Don't round it. You can use exact numbers. So I have 819.2 minus, I'll just go up and grab that answer, equals 776.53 repeating. And then I take away, let's see what 4/5 minus 2/3 is. It's 0.13 repeating. Okay, now what's cool about these calculators, you can just scroll back up, right? So now I'm taking this guy minus this guy. And I hit equals, and you get exactly 776.4 is the area under that crazy curve. I don't even know what that looks like, but from 1 to 16, the area under that curve is that. All right, so hopefully that helps. That's the deal there. All right, I'll talk to you later.